Hello everyone, welcome to this lecture. In this lecture, I am going to discuss the comparator. So in this lecture, I am going to discuss comparator. This is also one of the combinational circuit. Okay, so that means it doesn't have any memory element. The output will be dependent on the present input only, right? So what is exactly the comparison? How do we compare the numbers? Let's try to understand first. So I assume that, let's say, we are having some numbers, like I'm taking two numbers like A, B or X, Y, whatever you want. You can take like that. Okay. So let's say there are two numbers X and Y. There'll be four combinations. So in truth table, we make 0, 0, 1, 1, 0, 1, 0, 1 kind of combinations are possible, right? Now, if we compare these two numbers, generally the comparator can give you three possible results. So the numbers may be equal, or one number may have the lesser value than other, or one number may have greater value than other. So accordingly, let's say I assume that it is representing some place. So let's say I'm saying it is representing anything, like there are three functions finally we are going to generate. So y1, actually, let's say I'm saying y1 is representing when x is equal to y, or you can take a function maybe f1 if you want. So this is the final output, and this output we are assuming when x is equal to y is given. Now let's say I'm taking y2, and y2 I am assuming when x is having lesser value than y, right? So if x is having any lesser value than y, then we consider this is high. And the third possibility in case of comparator is when we assume, let's say this is y3, and it is having when x is having greater value than y. So these are the three possibilities in case of comparators which we have, right? There's no further possibility, only these three possibilities are there. So we can conclude this is the truth table like this. Okay. Like this. Now focus here. So we fill the values when we compare 0, 0. That means this place will be high. When we compare 0, 0, it is not lesser than, so this is 0, this is 0, and this is also 0. Now if you compare this one, x is not equal to y, so this is 0. X is lesser than y, so it will have value 1, and it is not greater than, x is not greater than y, so this is also 0. Now if we compare this, 1 is not equal to 0, so this y1 will give you 0, x is not less than y, so this will give you 0, y2 will give you 0, but y3 will be 1 because x is greater than y. Now in fourth case, because this is equal, this will give you 1 and rest of y2 and y3 will give us 0, right? So this is the scenario in case of comparator. Now let's say if we want to find out the Boolean expression for y1, y2 and y3. So what will be the Boolean expression for y1? It is very easy. It is taking at two places. It is high. So based on this and this, we can write the expression. So what is the possible expression? Here x is low or 0 and y is also. So you can say x bar, y bar, or the second is x, y, right? So this is the Boolean expression for y1. Now let's write the expression for y2. So for y2, what is the expression? If you consider y2 is high only at one place, and that is x bar y, x complement y. So you write here x complement y. So this is the possible Boolean expression, or Boolean expression you can say, for y2. y2 is a Boolean function, right? Because a comparator can give you three different outputs. Now let's write for y3. So what is the expression for y3? y3 is high only at one place, that is this. So when it is high, then we can write x y bar or y complement. So it is x y complement, x y complement, right? So you can remember these expressions. Now if you want to draw the circuit for this particular thing by using, let's say, NOR gate or NAND gate, we can do it. It is not very difficult to draw this thing. But a common circuit, if we want to draw, we can draw something like this. So a circuit we can draw like this. Let's try to understand this, how it is working like a comparator. So if we are taking here A or B, let's say XY we will take rather than AB. Let's take XY, because in our truth table I have taken XY. So I'm taking, let's say this is X and this is Y. Now let's try to find out how this circuit is working as comparator. So here, if we find out, this is actually giving us, this is X only. So this is X and this is Y. There's no problem. But here what we are getting here X plus Y whole bar. So if you consider X plus Y, the whole complement of it, ultimately we will get X bar dot Y bar, right? So here we are getting X bar dot Y bar. Now because we are getting two inputs here, X and X bar dot Y bar, so this will give us, let's try to understand what we are getting here. So here we will get X or X bar dot Y bar, the complement of this, right? Because this is NOR gate. So when we do this, we will get X bar dot Y bar whole bar of it. So this will give us X bar dot, this will give us X double bar that means x only, plus y double bar means y only. So when we solve this, it will give us x bar dot x, that will become 0, and then the next term will give us x bar dot y. So here we are getting x bar dot y, not y bar, y only, right? So here we are getting x bar dot y, because here it is y only, right? So this line will give us x bar dot y, right? Now let's look at the another line which we are having here. So this will give us, this line is coming as x bar dot y bar plus y and the whole complement of it. So this will give us x bar dot y bar whole bar dot y bar, and when we open it, it will give us x double bar, so x plus y double complement, so it will give us y, and then dot y bar. So when we open this, we will get x y bar plus 0, y along with y bar will give us 0 only. So this line will give us x y bar here. Now what about this, the middle output which we will get here? So at this place, what we are going to get, let's write it like this. So here we are getting two things as input. We are getting x bar y or x y bar whole bar, right? So when we open this, we will get x bar y whole bar dot x y bar whole bar, right? So when we open this, there will be x double bar, so x only plus y bar dot x bar plus y, because y double complement will give us y only. So here if we open this, we will get x dot x bar plus x bar y bar plus xy plus y by y, right? So this will give us 0, this will also give us 0. So the ultimate thing which we are getting here, that is x bar y bar plus xy, right? So here in short, if I write what we are getting here x bar y bar plus x y, right? So if you look at the previous representation, y1 is this, y2 is x bar y, and y3 is x y bar. So this is actually y1. So here we are getting y1, this is y1. Now here x bar y, this is y2, this is y2. So here we are getting y2, and the y2 is x bar dot y, and here we are getting y3, and y3 is x y bar. So this circuit is working as comparator, in which we can pass any two bits and this comparator will give us a result. So out of these three, whatever the terminal will get the high value, accordingly we will get, whether it is having lesser value, equal value, or greater value, right? So I hope this is clear to you. So with this, I'm closing this lecture. Thank you.